Course 3, Lesson 107, we are looking at volume and surface area of compound solids. We've looked at both volume and surface area of solids in many different shapes, but today we are taking more complex figures, things that you actually see in the world, and figuring out what is the volume and surface area. So most of the time when we are thinking about surface area and volume, we don't have perfect prisms or pyramids. If you think about your house, it's not just typically a rectangular prism and that's all. Typically there are different pieces that we can actually combine together to get our house or whatever we're looking at. Most buildings are complex figures. So complex figures, a definition for you, figures that are made out of two or more simple shapes. The volume of this isn't going to change very much, right? We're just kind of putting two different volumes or more together. But the surface area will, okay? And I encourage you to think for a second, why is that true? Why is surface area so different? Well, if you think about it, if I were to look at a figure like this, like a desk, the volume's not going to change much because I just have these two pillars and this top put together. But the surface area means cutting out different pieces that if I were to just have this pillar, I would be able to look at the top of it. I would be able to look at the bottom of it. But since we have this top on there, we have to get rid of that base. So the surface area does change quite a bit when we stick things together because some of them are not actually seen anymore. To begin this problem, we're going to look at both volume and surface area of it, but right now it's in inches, kind of bigger numbers. And we would rather work in feet. Okay, so let's convert all of these to feet. And just starting with some of the easier ones, like 60 inches, well, for that, we would just be doing 60 divided by 12, and you can actually set up those, our different fractions in order to do that, saying 60 inches over 1, and then saying 1 foot over 12 inches. On all of these, we are going to be dividing those inches by 12. So in this case, we would be getting, 5 feet. All right, another easy one, 24 inches is 2 feet. 18 inches is going to be 1.5 feet. Same over here. And you notice that both of these pillars that are holding up the desk are the same shape, exact same shape. Okay, so finally we get 30 inches, which is 2.5 feet. For both of them. Okay, just helps us work with some smaller numbers, and since we want the volume and surface area in feet, let's start by changing them to feet. So let's just find the volume of the desk a little bit easier here to start with volume, and we're just going to break it into 3 pieces, and this is what I would encourage you to do with any problem that you have with a complex figure, is break it into different shapes that you know very well. For instance, this top part of the desk, this longer piece here that sits on top of the 2 pillars, we can just find the volume by saying, well, it's a rectangular prism. I'm just going to do the simple length times width times height. So 5 times 0.5 by 2.5. Ends up that we get a volume that you can see right here of 6.25 feet cubed, since we're in volume. And then we can look at the second shape. We can look at those pillars and we say, all right, it's still a rectangular prism, so I can do 1.5 by 2.5 by 2. That means that the volume of each of those pillars is 7.5 feet cubed. But we have 2 of them, so I'll take 2. And you can see this is what we're adding up. 2 of the pillars with 7.5 feet cubed, and 1 of the top portion, the actual desk, is 6.25. Well, when you add those all up, you are going to get, well, 7.5 and 7.5 is 15, plus 6.25 looks like 21.25 feet cubed. Okay, easy here. Just split it up into different pieces. If it's rectangular prism, go back to your normal length times width times height. If it's any other shape, remember we have our formula, area of the base times the height. Now, a little bit more difficult, not by much, but just more to keep track of, is surface area. And it says, find the exposed surface area, excluding the part of the desk that sits on the floor. What we're trying to imagine here is if we have this original desk and I wanted to paint it, what would be the surface area that I would be painting? Well, if you think about this top portion of the desk where you would actually do your work on this desk, I am painting the top. I would be painting each of the sides, 1, 2, 3, and 4 sides. I would be painting this piece that's underneath, but only part of it because one of it rests on this pillar and another piece rests on this pillar. What I'm actually going to do is find the total surface area, so including all of the spaces, and then I'm going to subtract these amounts so that I get the accurate amount for the surface area. What that's going to look like is this. Total surface area comes from doing 2 times the area of the base plus the perimeter of the base times the height. Okay, so when we do that, 2 times the area of the base. The area of the base is this big piece up here. So 5 by 2.5. 5 by 2.5. And then I'm going to do perimeter of the base times the height. Let me get rid of a little bit of this so it's easier to see everything. Now that big piece is still my base, so I need to do perimeter of it, which means I'm going to be doing this side, plus this side, and this side, which means I'm going to be adding up 2.5 plus 5, and then 2 more of those, 2.5 and 5. And then we're going to multiply by this height of 0.5 times 0.5. Oops, went off the page there. 0.5. Okay. All of that together means that we have a surface area, and you can confirm this. When we actually multiply out and add it all up, we're going to get a surface area of 32.5 feet squared. But that's the total surface area. We have not yet gotten rid of these pieces that are sitting on top of these pillars. Okay, we're not going to paint that in reality, so we need to take those away. And the area of those pillars right here is going to be just regular area. In this case, it's going to be 1.5, since that's our side length right there, times 2.5. Okay, so we're going to subtract this 1.5 times 2.5, and we have 2 of those since we have 1 pillar and a second pillar. Okay, that's all to get the area of just this top piece, meaning that we get an area of 25 feet squared for that top piece. Now actually these pillars that we're going to do next are a bit easier. Okay, we just need to find the lateral surface area of those. Okay, if the top and the base of the pillar are not painted because they're not exposed, we just need the lateral surface area, which comes by doing perimeter times height. So for each of these pillars, we're going to find the perimeter of the base, which in this case, remember, each of these bases, I need to add up 1.5 by 2.5, 1.5, and 2.5. So I'll write that out. 1.5 plus 2.5 plus 1.5 plus 2.5, which means that when we actually look at this, we can say that the perimeter of this is 8 times the height here. We can see that height of, 8 times the height of 2. Okay, so each of those pillars has a lateral surface area of 16 feet squared, but we have 2 of those pillars, so we have a total of 32 feet squared for those pillars. When we add up all of this total surface area, we're going to get 57 feet squared. Okay, 1 piece of it coming from this top portion, and then the other 2 pieces coming from these bottom pillars, so that we get a total surface area of 57 feet squared. Definitely takes a lot more work for surface area, but a very good thing to know because we use it so much in real life to figure out how much area do I actually need to cover. Let's try another problem here, a little bit different. So it says find the volume and exposed surface area of the figure, excluding the base. So the base of this, the base of 3 by 3, we're not going to count in it because we can't see it. It's not actually exposed. And we say these are all 1-inch cubes. So if I look at this top one, it's 1 inch by 1 inch by 1 inch. Okay? Each of these is 1 inch cubed. So if I want to find the volume, that's actually decently easy. You can do it a lot of different ways, but on a simple figure like this, where I know all of the cubes are the same, I'm actually just going to count them up and say I have 1 cube up here, I have 4 cubes on this next row, and I have, well, 3 by 3, so 9 cubes on the last row, giving me a total volume of 14 inches cubed. Now you could do that a lot of different ways, going back to the original formula of area of the base times the height, or since we know they're all the same, we can actually just add them up. All right, so simple for the volume. Now for the surface area. I'm going to still go row by row looking at the surface area. And so I'll start with the first one. First row. I am actually going to do the lateral surface area on all of these and then add to it whatever bases are actually exposed. So for this first row, lateral surface area means perimeter times height. So perimeter is 1 inch plus 1 inch plus 1 inch plus 1 inch, so 4 inches times the height of 1 inch. Okay, so lateral surface area gives me 4 inches squared. And then I look and I say, well, the bottom base here, I can't actually see that, but I can see this top base. So I'm going to add 1 square inch to it, since that's a base that I can see, giving me for this first row a total of 5 inches squared. I'll leave that alone for a second. All right, let's look at our second row now. Okay, and I'm going to do it the same way. Perimeter times height. So perimeter in this case is 2 by 2 by 2 by 2. Okay, think about going all the way around. So we have 8 times the height of 1 is 8 inches squared, and then we can add to it however many exposed bases I can see. And on this top row I see 1 exposed base, 2, and 3, meaning that I'm going to add to it 3 square inches to get a total of 11 inches squared for the second row. Lastly, the third row, same way. I'm going to say I have a perimeter of 3 by 3 by 3 by 3, giving me 12, still a height of 1, gives me 12 square inches for lateral surface area plus 1, 2, 3, 4, 5 inches squared for the exposed bases. So I get a total of 17 inches squared for this last row. Adding it all up, 5 plus 11 plus 17, I'm going to get a total of 33 inches squared for the surface area. So volume of 14 inches cubed, a surface area of 33 inches squared. Okay, leave this as the last one, but there's going to be a good amount to do with this one. We're going to start with the easy part, the volume. Now, say this barn was created out on the farm somewhere, and it's basically 2 rectangular prisms on the base and 2 triangular prisms on the top, but there's some overlap. You can see this top view here, and we're going to actually use that top view for our volume. Okay, so I'm going to use this, and I'm going to first find the volume of these rectangular pieces. Now, lots of ways to do that. You could actually find the volume of each of these, so 16 by 20 is what we see here, and 20 and 16, meaning if I were to find this side length up here, I would be doing 20 plus 16, so 36. Okay, so if I wanted to find this rectangular prism in here, I could do that whole rectangular prism, and I could do the entire rectangular prism here as well, and then take out the area. I think that's a little bit too complicated, more complicated than we need it to be. I'm just going to cut it in 2 pieces. Okay, I'm just going to say I'm going to find the volume of this first rectangular prism and add it to this rectangular prism. So for the first rectangular prism right here, I would say that the volume of that is 16 by 36, so length times width, and the height is still this 10. Okay, and I'm going to add to that the volume of this one here, which in this case is 16 by 20, and then by 10, since that's our height. Okay, so 16 by 36 is going to be 5,760 feet cubed, and this 16 by 20 by 10 is 3,200 feet cubed. Now that's just the rectangular prisms that we have for this barn. I actually need to do these triangular prisms as well, but unfortunately there's not a great way to do it other than to actually find the volume of both triangular prisms and then take out the overlap. And if you look at this overlap right in here, the overlap would actually be a pyramid with a square base. Okay, it's hard to actually imagine this in here, but the overlap is this prism, or not a prism, a pyramid that overlaps between the two triangular prisms. What I'm going to do is find the volume of these two triangular prisms and then take out the volume of that pyramid. Since I counted it twice, I need to take out one of them. So let's start, and thankfully these two triangular prisms are actually the same volume. So I'm just going to draw one of them, okay? So here is my triangular prism. In this case, we have a height of 6, a base of 16, and a height, remember from base to base, of 36. Each of these is actually going to be the same, and you can prove that by using this top view by saying, okay, that height is 36, the base is 16, and the height of each of these triangular prisms that are in here are actually 6. You can see them in each. Okay, so I just need to find the volume of each of these triangular prisms. So I'm going to do, here we go. Volume is area of the base times the height. Now the area of the base in this case, since it's a triangular prism, we have an area of height, base times height divided by 2. So because that triangle is our base, base times height divided by 2. Then we're going to multiply by our height of 36. Remember, height in this case of the actual prism. So when we actually figure out the volume of each of those, we end up saying that it is 1,728 feet cubed for each of those, but I have 2 of them, okay, 2 of these pyramids. So I get a total volume of, let's see, 1728. I didn't actually work that out. You can work that out in just a second. It's not going to be our total volume though, because when we do this, we have an overlap. We have this square pyramid here, okay, that has a base of 16 by 16 and a height of 6. So let's actually figure out what the volume is of that pyramid that we've actually overlapped. We're going to do area of the base times the height, but since it's a pyramid, we're going to divide by 3. So in this case, 16 by 16 by 6 divided by 3 actually gives us a volume of 512 feet cubed. So when it comes down to it, we're going to have basically 1728, another 1728, minus 512 to get rid of that overlap that happened. Okay, when we actually work all of that out, we get 2,944 feet cubed. Okay, so to put it all together, we have for the one of the rectangular prisms, 5,760, another of the rectangular prisms, 3,200, and the top, the actual peaks of those roof all together would be 2,944. Add all of those up and we get a total of 11,904 feet cubed. Okay, a little bit complicated, but all we did was break it into shapes that we knew, and the hard part is figuring out what is that overlap for the roof. Okay, now I said that was the easy part. I actually forgot that that was the harder part of the 2 questions, because our second question on this building is find the total area of the building's rectangular walls. Dimensions are in feet. We only want these walls on the outside all the way around, okay? Think about that back wall and the other back wall. So we have 6 different walls to add up here, and we're just looking at the rectangular pieces, not looking at the roof. So I'm just going to draw this base again of this and say we have a base of 20 and 20, 16 and 16, which means we have 36 and 36 on these long walls. Well, what we're actually being asked to find is just lateral surface area. We just want perimeter of the base times the height. So we're going to add it all up. 36 and 36, 20 and 20, and 16 and 16. by the height of, still the height, 10. When we add all of those up, we're going to get 144 times 10 is 1,440 feet squared. Okay? And that's all that we do for that one. It would be more complicated if we were to try to add the roof in there, quite a bit more complicated, but for right now, all it wanted was those rectangular walls. Figuring out maybe if we were to just paint those ones, how much paint would we need? All right. So once again, when we're finding those lateral surface areas in general or volume of complex shapes, split them up into shapes that you know, and then you can add and subtract to get your total. All right, well, I hope this helps with your homework and for studying.